All right. So if you're not speaking, you can mute while we start, and then if you need to speak, just unmute yourself, and then we'll be able to hear you. So today we're going to just look at basic troubleshooting using 3 dynamic management views that are exposed in SQL Server. So if we remember the last time, one of the things we looked at was system views, and we talked about catalog views, dynamic management objects, compatibility views, and data application views. Of course, we talked mostly about the first 2, and we defined catalog views and we gave examples, and we told ourselves that they are used to view metadata, data about the database. We have basic structures of these catalog views: sys.databases, sys.indexes, sys.tables, sys.availability groups, and so on and so forth. And then we came down to talking about dynamic management views, and we said that the key word in these objects, this kind of objects, is the word dynamic. They have to do with transient states. A lot of the dynamic management views have to do with when you want to view things that are transient, data that is not static, data that is as a result of basic things that are mostly able to change in a more volatile manner than what you have in the catalog views. So we also talked about the groups, the 5 groups of the dynamic management objects. We have dynamic management views, we have dynamic management functions. Today we're going to focus on the DM_exec_star group, and these views contain information related to the execution of user code. We're not going to talk about all the DMVs in this class. There are hundreds of them probably. We're just going to talk about 3 of them, which if you have a good mastery of, at least you will be able to do a lot of troubleshooting in terms of who is in your server, what is it doing, is there anybody hindering him from doing what he needs to do, and so on and so forth. So let's start here. If you remember, I said that we can actually investigate the whatever we want about SQL Server on the docs.microsoft.com, which we typically used to call books online. So if I'm going to do a function F1, the SQL Server will open up the internet and show me the details of this dynamic management views that I have called in this query window. Now, if you want detailed information about them, you'll find them on Books Online. This is the first one, sysdm exec connections. Now, they are, the way they are named, you can see that they are intuitive in their name. So the connections, system exec connections, is telling me, give me information about all the guys that have established a connection to my server. In another way of putting it, every client computer or client device that has successfully reached my server, particularly at the network layer, it can see my server, I can see him. And then system exec session says, okay, every interaction that I have with a client's entity, whether it's a user, whether it's a job, whether it's a credential, whatever it is that has reached me as a server and established a relationship, and we are now about to start talking or interacting. So we have a session, and then we talk about system exec request. Every session in my server that is actually doing something, So we can think about it in those 3 ways. We can think about it in terms of the order in which I have written it. I have said connections first, sessions, and then requests. You cannot have a request coming from something that does not have a session ID. For example, a request implies that there is a session. A session implies that there has been a connection. So that's one of the things you have to remember in this. So one of the key, these are DMVs, so they have columns. One of the key columns that relates these three DMVs is the session ID column. And using the session ID column, we are typically able to create queries that will create joins in our queries that will be able to fetch different aspects or different attributes we want from these three DMVs and display them in one result set. So if I were to do a straight up query on sysdm exec connections, it will tell me every single entity that is connected to this server right now. And it gives me the session ID, the most recent session ID. What it means is basically the most recent session that has actually performed an operation, that is, has done a request. It tells me when the connection happened. It tells me what kind of transport layer protocol is it using. Typically, we are seeing shared memory everywhere because all of our sessions in this server right now are from this same server. So it's not using TCP, it's not using name pipes. Typically, if it's a production environment, you definitely see TCP IP there. Then protocol type, TSQL, version of the protocol. These now talking about database protocol, not network protocol, and so on and so forth. There are quite a number of them, and they all have their descriptions, like I said, in books online. Some of the really interesting ones you will need will be connect time, of course, the session ID. Definitely you need to know who is the client that is connected to me. You see, in this case, all of them local machine. If you have a production environment, definitely you will see the IP addresses of the machines where the connections are coming from. That's what you will see here. The last time there was an activity, a write activity from that connection, the last time there was a read activity from that connection, and so on and so forth. And then connection ID as a code. This is a GUID signifier, and then you have most recent handle, another encrypted identifier for the SQL handle. That's the most. This is the identifier for the SQL statement that was last executed on this connection, and so on and so forth. So you can use it to. There's another dynamic management function called DMExec SQL text. You can actually use it along with this to retrieve the SQL statement. So that is sysdm-exec connections, basically. Then request. In this my query sessions, sysdm-exec sessions, I'm excluding background sessions. When I do that, I see quite a lot despite my exclusion of background sessions. And then I'm going to exclude sessions that are coming from SA, so that I can see real user sessions that are coming in. SA, the security ID in SQL Server for SA account is 01. So by saying where security ID is not in 01, I'm excluding all connections that are coming from the default administrator account in SQL Server, which is SA. So it just gives me now all the sessions that are coming from actual users. Now, these sessions, this DMExec sessions DMV gives me a lot of attributes as well. Tells me the session ID, of course, the login time, the host name. That is this host name refers to my instance. This is my instance name, or this is my server name. Then the program. What program is this guy using to connect? Most of the connections are coming from Management Studio, as you can see, and some of them from internal SQL Server processes that are here. Then, of course, it gives me the process ID. And if you remember very well, we did this. We talked about this process ID before, where we said that if we check very well on the OS level, you can see this process ID matches the process ID that SQL Server is using, or that that process that is talking to SQL Server is using. This is 2596. 2596. So that is Management Studio, SSMS. That is the process ID for the tool that is connecting to me. This means that if I was doing this exploration in a production environment, this host process ID will actually be on the remote host. For example, if my server where I'm hosting SQL Server is server A, and I'm connecting to that server A from another server, an application server called server B, where I will find this host ID for this session, this particular one, host process ID, is on the app server that is connecting to me, not on my local DJV server. I'm seeing it here because all that is going on right now is going on this single box, excuse me, right? I believe that is quite clear. Then this 2752, let's find out what that is. 2752. 2752, that is this CEIP. It's one of the components of SQL Server that collects information about how SQL Server is performing. If you choose, typically you can send such information to Microsoft and so on. So there are other columns here, and one of the other important ones in SysDM exec sessions is the login name. You can tell who is logged on. I've created 2 extra accounts here for the demonstrations we're going to use, so you see them that they are logged in. They were logged in here, you know, in their extra sessions that are logged in on this server. You can see what the what kind of authentication they are using. That's somewhere here. Let me see whether it's here. Login name. There's an authentication mode. If I see it, I'll point it out. Okay, so then the status of the session. Is the session active? Is it running? Is it sleeping? That's another important aspect. The last time it initiated a request. Remember what a request is. A request in simple terms is an active session. How many reads that's done, how many writes, and so on and so forth. So the details of this are all on Books Online. This is another important aspect, open transaction count. If I initiate a transaction and I don't commit or roll back, you will see that you will see a count here. Typically, a healthy server, you should have this as 0, because when you have open transactions that have not been committed or rolled back, they can block other people. So I will demonstrate that when we do the demo on blocking and locking. All right, so then exec requests. Let's do this. Now when I query this, I have only one output. This output is coming from me, myself. If you can see, this is my session ID. So there's no other thing showing up. Why? Because even though these sessions are connected, they are not active. So I'm going to do something. I'm going to run a script on one of the sessions that will introduce a role.
Hello.
Yes, Prince.
Hello.
Hello.
Hello, sir.
Hello, I can hear you.
Please, I can't see your screen.
You can't see my
I
screen
can't see your
anymore.
screen.
Oh my goodness. Okay. Sorry, I forgot that. Okay. All right. Are you good now?
Yes, please, I'm okay. I can see now.
Okay, sorry. I've been talking a while. All right, so let me step back a little bit. I did some queries. I queried the SysDM exec sessions, and I talked about all the columns that are here, and then I queried SysDM exec sessions by excluding SA connections. That's connections from the default administrator account SA, and I also queried SysDM exec requests excluding sleeping sessions. And I was saying that in this case, only one row is showing up because I'm the only one active right now. Like I said, a request in SQL Server is basically an active session. So now what I'm going to do is I'm going to induce some work. I'm going to introduce some workload from another session, another connection entirely, this connection, yeah? Of course, you must have noticed in SQL Server, whenever you initiate a connection to a server, you can see who is connected right on this Object Explorer pane. In this case, this query is going to come from this connection belonging to eBen. And when I initiate this query, it's going to do an insert into a table I've created. Before I go there, I've created an environment. Basically, I've created these two tables, employee and department, and with their associated primary keys. And those are the tables we're going to be using to do our samples. So eBen is going to insert two rows into these employee table, and it's going to do it 20,000 times. I need to do it 20,000 times because I want the session to last long enough for me to be able to see it in sysdm exec request. Now, if this was a production server, that wouldn't be a big problem at all because there's always something going on, right? Okay, so that is it. So now what happens here, this is eBen session ID 55. Watch this, of course, session ID 55. And then what is it doing? It is doing an insert statement. SQL Server can tell. And then its status is currently suspended. This status is the status at the instant that you executed this query. You will realize that if your environment is very fast, very performant, if your server is very performant, you may not see a lot of sessions here, even though there are sessions going on. Because if it's so fast that the query cannot retrieve it quick enough, you will not see it like here. Now, this will only, you only see it showing up if, okay, it's done. So if you only see it showing up if maybe there's a little delay and you can actually catch the queries that are running. So yeah, fine. So it tells you it's an insert statement. It tells you the SQL handle. This is an identifier for the SQL Server, for the SQL statement that is running. It tells you a lot of other things. The plan handle, that is the execution plan handle. Database ID, what database is it actually running on? What's the user identifier, that's the user security ID. If it is waiting, if somebody is blocking this request or blocking the session, it will show up here. What is it currently waiting on right now that give us the opportunity to see the session in this DMV? What is waiting on is write log. This kind of wait event means that it got to a point where it needed to persist the changes it had made on the transaction log. How long has it been waiting? This is 50 milliseconds, you know. So if you want to know whether your environment is slowing down, this is a good place to check. What else? Last wait type, open transaction count. Is each statement in SQL is considered a transaction if you have not explicitly opened a transaction. So open transaction count 1, and so on and so forth. So a lot of other things there, but these are basic. Now we're going to do that again, and we're going to look at this. There's a query we normally use, which you're familiar with. In this, you discover that most of the time in production, you don't go querying these DMVs by themselves because the information you get is limited. But out there in the world, so many experts, so many senior DBAs, so many what do you call them, MCM, certified masters, have written scripts all over the place that you can use to interrogate these DMVs and more. This is one of them, and this is one I use a lot. Now, when I do this query, nothing is really happening, but I'm going to once again induce the activity that I want with this 20,000 rows. And once I do that, I can query, and then I'll be able to see that this guy is doing something. This is the same session ID eben 55. Now, in fact, what I can even do, I'll also open another session for Prince, and I'll just also run the same query so that we see multiple sessions happening. Is execute, and then I go okay. Okay, so we have both of them. Now this query, it has been designed in such a way that it leverages all the columns in these 3 DMVs and a few more, including sysdm exec SQL text. You will see that in this part of the query, it does a cross apply and passes the SQL handle to the SQL DM sysdm exec SQL text dynamic management function, so that it will return the exact SQL statement that is happening within this each of the sessions that we are examining here. It will tell us who is the guy who is executing, what kind of command is executing, where it is coming from, and these columns is speaking, and the host process ID. You can add a number of other columns. You can see the open transaction count that I mentioned earlier. You can add a number of other columns if you want. If you want to see something specific, you can add it up here. You can make modifications to the query to suit your requirements. And basically, you're beginning to get a good picture of what this guy is able to show you. Again, the wait seconds comes up here. You can check again. Once the query is completed, the requests are no longer there. But if, like I mentioned earlier, the difference between the requests and the sessions, basic, where is it? Yeah. So I can still see that these sessions are still connected. Let's exclude SE. These sessions, they are still connected. Eben is still here. Prince is still here. Eben is still here. Eben even has multiple connections, so on and so forth. But they are not active. So I don't see any results when I query, when I do a join that where sysdm exec request is participating. If the session is not active, it will not show up in sysdm exec requests. Okay. All right. So what else do we need to know? Sorry about that. Okay. Right. So we have been able to see that with these dynamic management views, we can actually see who is hitting our server and from where. The identity of the connection, the user, the program, the client tool, the identity of the host server, where it's coming from. We also see that we can know who is just an idle session and who is actively doing something in our server. All right, so let's do a little bit of a simulation so that we get a little more insight into what is going on our server. Let's do a little bit of a simulation. All right, so we have two of these guys that have established a connection to our server. Two of these guys that have established a connection to our server. Prince here, okay. So this guy, Prince, is connected to our server, and we are going to do, yes, we're going to open a transaction, delete from employee where F name is Janice, where first name is Janice, and then we're going to wait a little while, 10 seconds, and then start trying to insert into department. That is our second table. Then we're now going to go over to Eben's basic connection, and we're going to do something similar as well, the other direction. Then we're going to see what happens here. Okay. All right. Okay, good. So what we have done is we have created a lock modification. This is an exclusive lock coming from a delete. The blocking of this session, the session that is being blocked is session 55, who is eBen. You can see the guy is just hanging there, right? He's been hanging for 38 seconds, just going on and on. The guy that is being blocked is session 55. His status is suspended. The guy who is blocking him is session 57, who is Prince. Prince has finished his operation, but he is blocking him, and I'll show you why. Now he's blocking him. What is the kind of blocking that is happening here? Basically, there are many kinds of locking mechanism that SQL Server uses. This is a modification log. This is intent exclusive. Intent exclusive. That means eBen's connection wants an exclusive lock on the table employee because he needs to do a delete. He needs an exclusive lock on the table, yes, or the row, and he needs an exclusive. That's intent exclusive. But because of the kind of transaction that Prince has opened, Prince is not allowing him to take that exclusive lock. When you say intent exclusive, that means the guy who is coming he desires an exclusive lock, but he's not being permitted. He's being blocked by session 57. You can see what he's trying to do. He's trying to do a delete. If we query again, we should still see it because it's still hanging. And we see how long he's been waiting. He's been waiting for 117 seconds. He's just hanging there because the guy is blocking him. And he's trying to do that delete. The host process is there. Last request time, 1832, and so on and so forth. Open transaction. So you have two transactions open. So basically he's being blocked. Why is he being blocked? Because Prince opened a transaction with this command, begin tran. A transaction in SQL Server or in database parlance generally means is a unit of work. In the ACID mechanism, we say that a transaction is either completely successful or fails completely. So it's like a unit of work within database. So you have, in SQL Server, transactions are by default implicit. That means when you write a normal SQL statement in SQL Server, SQL assumes there's a transaction. So in the background, it does a begin and an end, a begin transaction and a commit or a rollback. So what is happening here is that this guy has begun a transaction, but he has neither committed nor rolled back. So because he has neither committed nor rolled back, his transaction is still open and he's blocking everybody else. If there are many other sessions here who are trying to access this table employee, they will also line up on this queue, waiting for 57 to finish what he's doing. And 57, the reason why he can't finish was this because he has not completed his transaction. So what we're going to do here, we invoke a rollback, and so that we can close up the transaction, and then 1 minute, I'll come back there. Then once we close up the transaction, it's up. But you see, there's another case here where what we have done is also invoked what you call a deadlock. A deadlock happened here in this case because we are interacting with two tables. This session started interaction with employee and tried to end it with department. This other session started with department and tried to end with employees. We're going to demonstrate that ever so clearly again with another set of queries. So we have eBen. We're going to just do it one by one. eBen opens the transaction. He's trying to update the department. Let's look at these two tables. Let's assume that, let's roll back eBen's transaction. Roll back eBen's transaction. Okay, you can see it's also blocking this guy. Where are we? So let's go to eBen deadlock. Yeah. So we had to roll back Eben's transactions to be able to do this fetch. So that is the problem with open transactions. In fact, I said I was going to demonstrate that. So let me just do it one more time. So I do this. You see, this time around, Eben is doing, Prince is waiting. Let's do that. Oh, come on, show me the lock. I think I didn't do the open tran. Prince, Eben opens the transaction, Prince opens the transaction, then we check what's going on. So they are both trying to run the transactions, both of them there. At some point, one of them should block the other. Okay. Okay, I think I've okay, let's see. Let's go back to here, basic, and check our sessions. All right, so this is what I wanted to show us. Open transaction count. Prince has 2 open transactions, right? What that is going to mean is that when I try to do something as simple as querying from this table, select this is the this table has only 3 rows, but I can't query it. Why? Because somebody is waiting on this is another kind of lock, right? A shared lock. S, when you see S. Remember the other one was an IX, intent exclusive. This is a shared lock. Select statements typically demand shared locks. Update, insert, delete statements typically will demand exclusive locks. Now session ID 59, which is this guy, Deadlock 59, is trying to query the department table, but he's being blocked by one of Prince's sessions because, as we saw earlier, Prince has 2 transactions open. He didn't commit, he didn't roll back. So his transactions are open. So they are blocking somebody else. You get? So let's see that. Let's go back to here. So when we query, this guy is just waiting. He's waiting for something as simple as a shared lock. He has been waiting for over a minute because someone did not close his transaction. So we have to either kill that person or that session, not that person, or we have to find who it is. Now, this, we can go here and go and issue a rollback or a commit because we know we can interact with this session. If it was coming, for example, from an application, the only thing we will be able to do is to kill that session. Kill 57, right? That is what we'll be able to do. And once we do that, we should have some respite. But you see, another session is doing the blocking. Who? Eben, because Eben also has an open transaction. Let's look at it from here. Where is it? Basic. Eben also has 1 open transaction. Let's query this again. We'll see that this must have cleared. All right. Eben has 1 open transaction. We've been able to clear Prince. Eben has 1 open transaction. In fact, we can make this clearer by just we'll just bring this guy to the front here. Open transaction count. All right. So you see that even this session, where we login name, right? this session has one transaction open, and because he did not commit or roll back, the guy who is trying to simply query this table is just hanging. And then we see that he can block sessions indefinitely. This has been going on for 1.5 minutes. We have to kill it again, or we have to go to the session that is responsible, that's 55, and do a rollback or a commit. Once we do that, we should be able to clear this, and it's done. Okay? So some of the things you will see in production environments are as a result of bad programming or some problems. Maybe a particular application has established a session with the database, said there's some network glitch, it's performing a long-running transaction, and in the middle of the transaction, the connection breaks. So he has done a begin tran somewhere, then this network breaks, he didn't get the opportunity to do a rollback or a commit, and then that says that transaction is open. So if you go and query, what we queried earlier, the basics, that is system exec session, you can tell whether you have any open transactions that are blocking your sessions. When you find them, you'll be able to address them. Ideally, your open transaction count should be 0 or should not be more than 0 for a reasonable length of time. In production environments, you definitely see cases where it goes to 2, 3, 4 and then comes back and so on and so forth. All right. So we just demonstrated a little bit of locks and deadlocks. I said I was going to go step by step in demonstrating a deadlock, and then we'll see what it looks like in Profiler. See what it looks like in Profiler. Okay, so let's start from here. Even deadlock. So the even just queried, and there are 3 departments, 3 rows in the departments table. Something has happened. The manager has, somebody has been fired or somebody has resigned, and we need to update the manager. So we're going to say we want to make the manager for the department called information technology. You want to change the manager to manager number 10. So we open a transaction and start doing that. Now while sorry about that, yes, begin try and open, it starts doing that transaction. This is even Deadlocks. Then Prince, on the other hand, he wants to do something similar but in the reverse order, right? He wants to delete the employee first. Then Eben continues his task, and then Prince also tries to complete his task. And let me go to Profiler. I should have opened this ahead of time. I should have, but I will repeat it. Okay. Sorry, I think I have to bring my Profiler here so that you can see all the selections I'm making. Okay, so I basically new trace. I log into the instance. Now, of course, most people who know SQL Server Profiler know that it's kind of like old school. It's kind of old school. Oh, sorry, I think something. Let's start that again. Okay, good. All right. Okay, that's fine. So I have Profiler. I want to track the deadlocks, and when I do that, I'm going to, simulate my deadlocks again. By this time, one of them has been terminated. You see, when you have a deadlock in SQL Server. SQL Server handles it automatically, as do many other databases. The deadlock simply means that I start a transaction using a particular sequence, A, B, C, D, E. Somebody else starts another transaction using the sequence E, D, C, B, A. That's the opposite direction. At some point, we are waiting for each other. So one of us has to give in. It's like you're on the staircase. One person is coming up the stairs, another person is going down the stairs. You meet each other in the middle of the staircase. One person has to give way. So what SQL Server does is that he has to choose who is the cheapest person to kill. So he says transaction process ID was deadlocked on resource with another process and has been chosen as the deadlock victim. So this guy was chosen as the victim because typically there are a lot of calculations SQL Server will do internally to determine who is the most viable victim to be terminated. You get who is the cheapest person to kill, basically. I'm sorry about the kill word. Now, so it does that. It terminates it so that at least the other one, at least the existing one, that is Prince, will be able to complete
that's not fair now.
No. Otherwise, the whole server will be blocked. He has to choose one person. He has to choose one person who is cheaper to kill. That's what it does. Everybody does that. Otherwise, both of them will stand at the staircase looking at each other forever. You get? So that's the way it is. So we're going to do that again so that we can see it in the deadlock graph. I'll roll this back. I'll go back to EBEN. EBEN's deadlock. And I'll roll back again. Of course, this has already been killed. It's already been killed. So you won't see any possibility of rollback. Then we'll start it again. So EBEN initiates this first. And this guy initiates the same. Then EBEN tries to do the next step they're still within the transaction. Prince also tries to do the next step. Remember, they are in the opposite direction. So where's my profiler? Okay, so we now have a deadlock graph. What you call a deadlock? It has captured the activity. Let's zoom in. Let's zoom in more and see what's going on here. Okay, so what it's telling us is that you have two processes. Process 59, that's basically the session ID. Then 61, right? Process 50, now there's an owner here, there's a requester, there's a requester. Okay, and both of them are asking for exclusive locks, X. They are asking for exclusive locks on these resources. HOBT means heap or B tree. What it basically means that the object that we are dealing with does not have a clustered index. So that's why it's being referred to as a heap or a B tree structure. So this is looking for the index name that is here is a primary key, employee ID. The object name is employee. So what is happening is that number one, this guy was killed. That's why you see the X there. This guy was killed. This is the deadlock victim. The first thing that happens here is the guy starts on department, requests an exclusive lock because he needs to do something. He needs to do an update statement on department, right? So he requests an exclusive lock on department. Then this other guy starts on okay, let me start from starts from employee. He wants to do a delete from employees, right? Now this guy is asking the other guy, I need to delete on employees, but this guy is holding on to employees. He's the owner of employees table at this point, owner of the session. So but because he has not finished all his statements and his transaction, he has to tell this other guy to wait. Now let's go back and compare what we are seeing. See session ID 61. Session ID 61 is this guy. The first thing he's doing is the delete from employees, right? when he is doing a delete from employees, he basically has ownership of employees. That's what we're saying. Then he goes to the second step and he wants to do an update on on department. But while he's trying to do that, the owner of manager at that point, the owner of department at that point is the other session 59, because the session originally took hold of the manager, I keep calling it manager, originally the session 59, where are you? 59, yeah. Initially took hold of the department table, right? So he was the owner at that point. Now, because he's the owner, the guy who started with employees has to ask him for an exclusive lock on the department table. Before session ID 61 can finish his own processes, he needs to complete this update on department. So he needs that table from the session ID 59. But session ID 59 is holding on to that table and is also asking for employees, which 61 is holding on to. So one of them has to give way. SQL Server decides, I'm going to kill this guy so that session 61 can have the other table department and be able to complete the transaction. So that's what this deadlock graph is basically showing you. With deadlock graphs, you can if it's in a production environment, you can actually analyze patterns and know whether somebody has done the wrong coding or whether applications are conflicting. For example, where you have this kind of thing is typically, let's say you have a core banking application and everybody is plugging into it from different applications. There's no serialization. There's no guy who's coordinating the accesses. Maybe there's a table called transaction log table. And you have different services. You have the mobile application, the mobile app service coming. You have a remittance application coming. You have a, what else? Maybe you have a loans application coming. All of them are having their own separate sessions on that one core banking. They will definitely create locks. And once in a while, they will create deadlocks. And the more deadlocks you have, SQL Server has to spend a lot of energy killing victims, terminating victims. You have to spend energy terminating victims. So when you analyze the patterns in these deadlocks, typically the most reasonable thing to do is to redesign the way the application works. The applications work together to access the DB so that they will be properly serialized. That's the reason for things like maybe the ESB arbiters, where the ESB is the guy who is connecting directly to the DB. Anybody who wants anything has to ask the ESB. That way, there's only one session coming. He's able to give everybody what he wants in a coordinated manner. Notice the thing we did with the deadlocks. In this case of the deadlocks, this guy is starting from employee and going to department. The other guy is starting from department and going to employees. So the transaction is not written in the same way, serial. When you write applications like that, you will cause a lot of what? Deadlocks. So with the deadlock graph, and this deadlock graph is also available in extended events, you can analyze the deadlocks and know what the patterns are and what to advise. You can tell them, oh, every time I'm always seeing that sessions from so and so are trying to do the opposite of what sessions from so and so are trying to do. Can we find a way of, redoing the application so that we can have something more serial? Now, a deadlock is basically an unresolvable lock. Typically, there's always a lock, and you can reduce locking by proper application coding. You can also reduce locking by doing other database side things. For example, you can implement what you call an isolation level that has a snapshot isolation level. Read committed snapshot. That way you have versions of your row which when somebody wants to read, he can read, because SQL Server by default, when a shared lock is desired, when a shared lock is desired, one who has an exclusive lock can block that shared lock, which means writers can block readers in SQL. So you can see somebody who wants to just read is blocked, except you use an isolation level that is a snapshot isolation level. So those are some of the things with the locks. So using these tools and these dynamic management views, we can have a little bit of insight into what is actually happening inside the database and be able to isolate a few things like locks, be able to know what session to kill, be able to know which applications are causing blocking, be able to know where deadlocks are coming from, be able to know who logged on, when, from where, for how long, is he making a request or is he not making a request, and so on and so forth. So what else is left? All right, we'll just do one more thing before we go. Execution plans, where the value, this is where you may see more of the value of Profiler and what we are finding out from the DMVs. Now let's go back to this query that we had that was doing 20,000 inserts. We're going to, first of all, let's turn on another trace. Let's forget this trace, stop this trace, do another one, a new trace, and yes, new trace. And we just want to find out what exactly is happening. Let's see, SQL. Query processing. Let's see. Okay. Now, normally there's the template here. I think there's something not right with my installation. So we have to do it ourselves. Okay. T-SQL. Let's just do batch queries using progress reports. I think am I missing something here? Okay. All right, no problem. So template name. I don't. Okay, let's start from the beginning. Stop this. There's something wrong with my installation. All right. Okay. Okay. Oh, that's what I was looking for. SQL executed, completed, recompile, starting. What else do we need? I don't think we can get anything here. All right, so let's just do this just to see. And using Profiler is a whole tall list of stuff which we can dig into in another session. I'll just start this query and then let's go and see what this guy is doing. So every single thing that is happening is capturing, batch completed. So you can capture my statements. Batch starting, statement starting, yes. So now, assuming this is, yeah, so whatever. So it's just for us to see, it's just for us to see that we can pick up the query from here. In a production environment, it definitely will be more complex queries. And then we can go on ahead and evaluate that query, whatever it is. Let's stop this. Can evaluate it, copy it, yeah, come back to SQL, and then go and check whether we don't need to run it, we can do this estimated execution plan, estimated, yeah. And then we see, okay, what's happening here? Typical execution plan, you read from the right to the left. Scan, nothing much. So, clustered index, insert. Every single statement here is a topic. So, you may not even know everything that it's saying. But what you want to look out for, where is the top, where is the most troublesome node point, and what is happening there is something you have to investigate. Now, clustered index seek. There's a primary key here which came along with the index. So basically, it's able to do a seek. That if I delve into what a seek is, that will be delve into indexes, but just know that seeks are better than scans. They are faster and so on. So we can read, you can pick out the query and read the execution plan and know what it's doing. Let's try to create a query that will generate a recommendation. So we can see a simple way to stop this, roll it back. Okay, a simple way to improve performance on our servers. So let's start from employee where. Now let's even see how much records we have in employee. Okay. Let's see. Okay. Yes. So that means, or maybe somebody is blocking me again. Somebody is blocking me. Blocked by 61. Who is 61? Who is 61? Yes. So let's roll this back. All right. So let's go. 61. 85,000. So let's go and do where let's just pick one of the, let's say last name, L name equals to, what's this Janice's name? This Janice's name is Amar, right? In fact, let's not do Amar, let's do Igiri. The reason why is, let's just take the execution plan. Okay, so basically, all right, probably not going to get the kind of demonstration I want to get now, but I can do another kind. I still uses the PK. Okay, select star from employee into employee copy. Select star into employee copy from, sorry about that syntax error. So we're creating another table, and let's see what it looks like. Let's do this again. All right, so now again, I didn't get the recommendation I wanted, but at least you can see the difference. Let me show you the difference I'm trying to show you now. Employee. This is a simple execution plan read. Basically, this is the same query but hitting different tables. One is doing an index scan. One is doing an index, a table scan. Table scan means I'm going to have to read all the pages associated with that table before I find my record. Index scan means I'm going to scan the index. I'm going to read all the entries in the index associated with that table. This is better than a table scan, but the best you want is an index seek. Assuming, for example, I now decide to create an index with index IXL name. On what? On this table, let's say we created on employee on the L name column. Okay, I hope my syntax is correct. Good. So let's look at what this execution plan shows this time around. So this time around, I changed the execution plan entirely, and it now is going to do a key lookup first of all, but it's going to do an index seek. Yeah. Basically, if you're doing an index seek, basically, there's something called a B tree in an index. You're traversing that B tree much faster than if it was all jumbled up. You can think about it like this. Think about it that you have the index of a book at the back of a book, but it's not alphabetically ordered. What that means is that you have to read every entry in that index because you don't know which area it may be in. But when that index is alphabetically ordered and they say look for the item Corona, if you like. If you know Corona, you will not go to the back of the index. You come closer to the front of the beginning part of the index because you know that ABC, C is likely to be closer to the front. So that way it's faster to navigate that index of a book. The same way it's faster when you see an index seek, it means that SQL Server is navigating the index B tree in a more efficient manner than otherwise. And the reason it's being able to do that in this case is because we have provided it an index specific to that query on the L name column. Now, the reason why this comes in here is because we just talked about Profiler and other tools that can help us capture queries. Now, when you are able to capture queries, what I will typically do, there is a template that is called the my profiler is misbehaving today. I don't know why. There is a template on Profiler called the SQL duration, and you'll find similar things on extended events. Duration, it basically will order this SQL statements by the longest running query. And what you want to do in optimizing the environment is to find the longest running query, then bring it into SQL Server and evaluate the query. Run your execution plan, do an estimated execution plan in the query, find out how it is being executed, find out does it need an index somewhere, is it doing table scans, is it doing hash joins, is there too much data moving. I mean, reading execution plans is a much bigger topic, but the point is you should be able, sometimes it will actually advise you and tell you, look, just put an index here, you'll be fine, and you'll be able to do it. So those are some of the things we can get from these DMVs and being able to implement it. So we've talked about a lot, and at this point I would like to take questions. If I can answer them, I'll answer them. If I cannot, I'll refer you to Microsoft documentation. So any questions, any feedback, is there anything that is useful to you? Is there anything that you want to clarify? So go ahead. Hello, Prince.
Yeah, hello, sir.
Yes.
I'm here.
So go ahead.
Okay, so I have a question with the index.
Okay.
Okay, so with the indexing, when you create it, you specify the nature of how it should look into the table for you, or how is it?
No.
How is it done?
No, this is a simple statement to create the index. What you're specifying is the table name and the column on that table. Now let's open this so that we see it clearly visually. This is DMV. These are tables. Sorry. Okay. This is employee. These are the indexes. So all we did was to specify that we want an index. This is the name of the index. We want this index on this employee table, and we want this index on a column called employee. Now, you can create indexes on more than one column that are part of more than one column. If you do this graphically, there are two kinds in this respect. You have, well, three kinds right now because of column store. But typically you have a non-clustered index, you have a clustered index. Clustered index means an ordered index, means it is arranged in a particular order, and it's better for primary keys. You can have only one clustered index in a table. Typically, otherwise, you have a non-clustered index. Where is it? Okay. So in this graphical, you can see you can add the number of columns that you want as part of the index. Provide the index name. You say whether it's unique or not. Unique means basically that every record there, it basically becomes like a unique key. And for you to make, for that to work, maybe it's something like a staff ID. Everybody has an individual staff ID. There's also something called included columns, where the columns are not really part of the index, but when you are using the index, you can actually query the data from those included columns. You call them covering in, call that kind of index a covering index. So those are the basic things you provide. SQL Server now handles how that index is physically structured. And when you have an index on the table on a particular column, SQL Server also decides whether that index is worth using or not. So normally, if you do the execution plan stuff, it can actually advise you which index to create that will be worth using. Sometimes if you want to go deeper, there are a lot of analysis you have to do to know whether overall that index will help your environment or not. These ones are quite simplistic.
Okay. I'm good. So let's take our environment, for example. At what situation does an application person actually create an index on a table? When there's a performance issue or what?
Yeah, okay, let me describe how an index helps performance. I always use the analogy of a book. Let's say you are reading a book that is 10,000 pages long. It's a medical book. And you want to, it has many chapters, and then you want to find in that book, you want to find cranium. You want to find information about your cranium, right? Now, the book does not have an index, so you have to now open every page to look for where cranium is, or open every chapter, right? But you know what the index of a book is in the first place? That portion of the book at the back of the book. Where you can just, yeah, of course.
Yeah.
So if without an index, you have to go through each page, maybe scan through the chapters to find out where you have any information about the word cranium. When you have an index at the back of that book, now for you to find that cranium information, it will take you quite some time because the book is a big book. Let's think about that book as a table. When you're doing a table scan, that's what you're doing. You're going through the pages of the book to find out where you find cranium. If you have an index on that book, you just go to the back of the index, and the index is already clustered, it's alphabetical. So you navigate to where you have the letter C and look for cranium. Then that index will now point you back to the book, right? So the index always points you back to the table and says, okay, look, this is where this information is. That way, SQL Server knows, oh, this is where it is. I don't have to scan the whole table. I have to go straight to where it is physically based on what the index has told me and fetch the data. So that's what makes it improve performance. So when people see, this table, when application guys see this operation is slow, and they know the tables involved in the operation, they do some analysis and say, okay, the tables involved are this, then they look at the query that is involved in touching that table. They see where the where clauses are and know, okay, the where clause is looking at column L name. So let us put an index on L name. That's a simplistic way of looking at it. That that thing you're doing may have other impacts, right? But the simplistic way is that if you have a where clause that is saying L name equals to Igiri, if there's an index on L name column, it will help the query run faster. That's a simple way of looking at it. You get my point? But like I said, I should have demonstrated that. Like I said, when you use a tool like Profiler and then you get the query that is a slow query, and then you use a tool like estimated execution plan to display the estimated execution plan of that query. Typically, if that query needs an index, SQL will tell you, and it's a fast and quick way to do it. It's not always that you just take that recommendation blindly, but most of the time it helps, especially for applications that have not been so mature, so they didn't even do the proper indexing in the first place. You get my point? Okay. This is similar to what an ADDM will do for you on Oracle. You get an ADDM, or they will just recommend, okay, you need an index on this table, and so on. All right. Any other questions?
Okay, so last question has got to do with the query, the select query on one of the, you said for MS SQL.
This one.
Connection.
Okay. No,
yeah, very good.
SysDM
with this query,
yes.
With this query, okay. With this query, is it similar to sys.dm DM underscore execution underscore connection?
Can you
Like
see
you
this?
run this query, does it correspond to the same query?
Not at all. Can you see this?
Yeah,
Look at this.
yeah.
Look
Yeah,
at
I
this.
can see, I can see.
See, so what he's doing, like I said, is he's doing a join between this exec sessions request and then another dynamic management function called DM exec SQL text to pass the SQL handle to get there. So he's doing a join between two tables and then doing a cross apply to a function to get all the columns that it needs. And you see for each column, you have to specify where that column is coming from. R for request, S for session, and so on and so forth. You get? So, like I was saying that typically, you will not do any reasonable extensive troubleshooting with these dynamic management views by querying them individually. You have to combine them. And people have already written scripts that combine these dynamic management views that you can use. But the reason why you want to explore what they mean, what these DMVs do, is because you want to try to understand the queries better and be able to modify them to suit your own purposes. You want to know what the columns mean. You want to know where on what condition it is doing the join, and so on and so forth. You get the point?
Okay. Thank you. I'm okay now.
All right. Okay, thank you very much for that. We have done 1 hour plus.
Theo has joined. I don't know if he has questions.
Okay, Theo, any questions? Or at which point did he join?
Steve.
Hello?
Yeah, hello Ken. Hi.
I'm fine, how are you?
I've been tuned in for a while now.
Okay,
I was
cool.
watching you, so yeah, I learned quite a lot. But it's actually new for me though, so I still have to revise on it.
Okay, that's fine. So that's fine. Just look at it and then any questions, let us know. And try to practice it. Try to check the references in docs.microsoft.com. Okay, thank you very much for your time. So I'll just the recording will be there too.
Okay, thank you.
And then we'll probably have another one.
So when will be our next?
I'm sure it will be probably Friday next week. What we can try to do is to do Friday and Saturday so that it will be faster. You can do Friday and Saturday so that it will be faster.
Okay, sure.
So depending, if Eben still comes, because he is the one that originally asked for it, so we were going in the direction of querying. That is the direction of querying, not actual core database. If Eben still makes himself available, we can go in that direction. It will still be useful. Otherwise, we can also go in the direction of core DB aspects.
Okay.
Okay.
All right. Thank you.
All right. Thank you very much. Yeah.
We appreciate.
Yes, sir. All right.
Thank you.
Take care.
Bye.
Bye.